Okay, so let's say that we have two functions, f of x equals 2x minus 3 and h of x equals absolute value of x plus 3 minus 2. We can try to get a graph of each and see what happens. So our goal here is to be able to use the graphs to come up with the graph of the composite function. In other words, a function of a function. So we're going to be looking for either f of h of x or h of f of x. So let's start with an input of -2 for f. So f of -2 is equal to, well, we just use 2x minus 3, so 2 times -2 minus 3. And we just evaluate. 2 times -2 is -4. Minus 3 gets you -7. And if we use Desmos, we can find -2. Indeed, the output is -7, and it will even put that purple point there for us. So let's go back to the table, and we can try to find another one. Desmos, of course, will just tell us the answer, but we want to show our work at least one more time to make sure that we know what we're doing. Right. So let's try the next whole number, which would be -1, next integer. So f of -1, and we're going to do the same thing we did before. We use f of x equals 2x minus 3, but this time we're using -1 as our input. So it would be 2 times -1 minus 3. Which is -2 minus 3, which is -5. Desmos agrees, and there's the other point. So we can keep doing that, or we can just have Desmos do it for us, and we have all those points. You can see them popping up on the screen there. Great, so now we have a graph of f of x, but only for those points on our table. If we want to connect them and find all the possible points, we can make our line, and we'd like to see arrows at either end showing that it keeps on going. Sorry about that. All right. So let's go ahead and move that over, and we'll start to graph h of x equals the absolute value of x plus 3 minus 2. And we'll do it the same way by actually inputting some values in for x. So let's start with -7 is our first input. So we have h of -7 is equal to the absolute value of, well, x plus 3, but our x is -7. So our absolute value of -7 plus 3 minus 2. All I did was plug in -7 for the x, because -7 is our input, and we're trying to find the output. So that's the absolute value of -4 minus 2. And the absolute value means distance from 0. So -4 is 4 away from 0. So the absolute value of -4 is +4. So we have 4 minus 2, which of course is 2. And we can look at Desmos and see if Desmos agrees with us. We can put -7 right in there, and indeed 2 comes out. And we can see that plot, -7, 2 on the graph. And of course we can do one more just for fun. And we can try the next integer higher than -7, which is -6. So let's try h of -6. So h of negative 6 is equal to absolute value of negative 6 plus 3 minus 2. I'm sorry, absolute value of negative 6 plus 3 minus 2. There we go. And negative 6 plus 3 is, of course, negative 3. So we have the absolute value of negative 3 minus 2. And absolute value means distance from 0. So negative 3 is 3 away from 0. So the absolute value of negative 3 is positive 3. So we have 3 minus 2, which, of course, is 1. Let's see if Desmos agrees. It does. And again, we can see that plotted point. And let's let Desmos do the rest of the work for us. There we go. We keep on going. And those are all the points that we had in our table. But we want everything so we can connect the lines. And there's our graph. All the points that are on that line. Not just the ones that look like dots, right? We'd like to see arrows. That's not shown, but we'd like to see arrows that show that it keeps going in both directions forever. So we have our graph of f of x. We have our graph of h of x. So we want to find the graph of a composite function. So here are the same two graphs. The colors have changed, but the graphs are the same. So we have here on the same coordinate plane, we have f of x in red and h of x in blue. So our table here for Desmos has h of f of x. So that's what we're going to try to graph. So let's go ahead and start off with negative 2 as our input. So we're trying to find h of f of 2. We just input the negative 2 in for x, because that is our input. So in order to find h of f of negative 2, we have to find f of negative 2 first. Sorry about that. All right, so we're looking for h of f of negative 2. All right. Sorry, it's slowing down here. And we have to find f of negative 2 first. So if we go up to our table, we can find it. This is the table of h, but we're looking for the table of f. There it is. And when x was negative 2, f of x was negative 7. In other words, f of negative 2 is negative 7. So I know what f of negative 2 is. So it's negative 7. So all I have to do is find h of negative 7. So we can look back at our table for h now and find h of negative 7. There it is. All right, there. So h of negative 7 is just positive 2. So when x is negative 2, h of f of x is positive 2. In other words, h of f of negative 2 is equal to positive 2. So if our negative 2 is our input, positive 2 is our output for h of f of x. There it is in green. We have that 1 point. So that was a lot of work just to get that 1 point. And we need to have lots of points so we get the general shape of the graph. So another way to go about trying to find the composite graph is not to look at the table and just to look at the graph itself, the graph of f, and then the graph of h. Because a graph and a table are really the same thing. A graph just has all the points, whereas the table has only select points that we chose. So whatever you feel more comfortable doing is fine, although you should be able to do both. So if we wanted to find our answer, again, of the one we just found, right, we can find f of -2, which is circled right here. Right? So when x is -2, f of x is -7. That's that point right there. That's equivalent to what we found in our table. So now we use -7 as our input for h, because we're trying to find h of that. And h shows that when x is -7, h of x is +2, which is what we found when we used our table. So when x is -2, f of x was -7, and h of -7 is +2. So our answer, our output, when x is -2, our output for h of f of x is +2, or h of f of -2 is +2. So we can do it again for when x is -1. So when x is -1, we have to find our output for f, because we work from the inside out. We have to find f of -1 first. We found that, -1, -5. All right, but -5 is not our output for our composite function. That's our output for f. So we find -5 using that as our input for h to find the output. And the output is 0, according to the graph. That's that point right there. Let's see if Desmos agrees. So, yep, when we type in -1 for our input, 0 is our output for h of f of x. And if we use 0, we get -2, and Desmos can do the work for us. And we can see what the graph looks like. It's those green dots right there. And if we wanted to get the whole picture, it might be easier to see if we turn off h of x and f of x. We take those off. Alright, so now we just have the green dots, the green points. But of course, h of f of x has more than just those points. So let's graph the whole thing. And there it is in purple. So we can either use the table to find the composite function, a table for the composite function, or we can go straight from the graph, whatever you find easiest. If you find using the table easier, that's fine, because you always can make a table out of your graphs. So if you're only given the graphs, go ahead and make a table out of it if you find that that's going to be helpful. The end.